Stop.
In the past, many accidents happened due to stall, despite the installation of various warnings and safety devices.
Stall.
Fly-by-wire technology offers the possibility of protecting airplanes from stalling. These protections may be soft or hard. At the beginning of the development of the A320, Airbus made the choice of hard protections that cannot be overridden. Whatever his action on the stick, the pilot is prevented from exceeding an angle of attack too close to the stall. The angle of attack limit is called alpha max. During the development, several flight tests are carried out to tune this stall protection, thanks to various maneuvers. On a specific display, the pilots monitor the key test parameters obtained from the flight test installation: angle of attack and sideslip. When a pilot pulls full backstick, the airplane must reach alpha max quickly. If he maintains the stick in this position, the angle of attack must then stabilize. The requirements of a fast maneuver and a good final stabilization lead to a motion where there is initially a small overshoot of alpha max, a decrease of the angle of attack, and then a progressive stabilization. On their displays, the pilots can see the following speeds associated with the protection. VLS, the lowest selectable, is the minimum operational speed. V alpha prot is the speed corresponding to the activation of the protection, and V alpha max, the absolute minimum speed with the protection. Airbus aircraft are equipped with a device called alpha floor, which avoids reaching too low speeds. Above a given angle of attack, or when the pilot pulls full backstick, it triggers a thrust increase to the maximum. Alpha floor must not be activated too easily, by a small gust, for example, to avoid unnecessary destabilization for the crew. When a protection is installed on any system, the operator must rely on it, whatever the circumstances. There must be no hole in the safety barrier. This is one difficulty in designing the stall protection, as some unexpected maneuvers may be performed by the pilots. Accumulated experience, however, now allows all these situations to be covered. The design and the tuning of the protections can only be performed with a very good knowledge of the aerodynamic characteristics of the airplane up to stall. Therefore, the first step is to carry out stalls in direct law, without protections,
Stall.
in all configurations and at the limits of the center of gravity position to identify these characteristics. After an initial tuning, the first tests of the protections are performed in a simulator. Then in flight, the development maneuvers are executed with a gradual progression in severity. They're carried out first with a mid-position of the center of gravity, then at the forward limit, and finally at the aft limit. The tests are performed in the following order for each position of the center of gravity. The first maneuver is a slow deceleration, wings level, engines at idle, until full backstick is reached. It is maintained several seconds to check the angle of attack stability. The second series of tests is the same slow deceleration, with increasing thrusts up to the maximum. With any thrust, some roll maneuvers are performed at alpha max. Initially with small stick deflections, increasing progressively to the maximum, and finally with abrupt reversals. Sideslip must be well contained. Then, starting from various speeds above VLS and with different thrusts, fast pull-up maneuvers allow the dynamic of the stall protection to be checked, and also possible interferences between two protections, maximum pitch attitude and stall. Some dynamic maneuvers are carried out during turns, but it is usually not critical due to the higher speed. The avoidance maneuver, with simultaneously full backstick and maximum roll, as if avoiding a collision, is usually not a problem with a protection that is well tuned. After the initial tuning, these tests are repeated with ice shapes installed on the leading edges. Sometimes it is necessary to reduce by ½ a degree or 1 degree the maximum angle of attack in some flaps configurations. One difficulty in the tuning is linked to the pitch up that may exist in some flaps configurations. A pre-command on the elevator may oppose this pitch up, and this needs to be properly adjusted. On Airbus aircraft, in case of loss of low-speed protections, the same stall warning that exists on non-fly-by-wire aircraft is available, with an automated voice alert
Stall.
associated with a visual warning.